Hello guys, today we're going to learn how to make a game in Python using Kivy. So we're going to use the popular snake game as an example. We're going to build it from scratch. So let's see how fast we can do this. Okay, so let's start by declaring some global variables that we're going to need throughout the game. We can start by declaring a global sprite size. All the entities in the snake game are squares. So for this I'm going to use a useful Kivy function, which is in the Kivy.metrics module, and it's called SP. What SP is going to give me is scale dependent pixels. This is going to allow me to have an application that if run on the computer or run on the cell phone, it's going to look like it has the same ratio. So next we're going to declare how many columns and how many rows the application is going to have. So the playground, we could call it the playground. So I'm going to use the Kivy window module for this, which is going to give me the window height. So I can do this, for example. I'm going to see how many columns of the sprite size 20 SP can fit in the window. So I'm going to do window.width divided by sprite size, and then I'm going to do the same for the rows, but using the height. So this will make our app adapt to the screen. If it's run on a computer or a cell phone, it will always fill the screen and use the square size of 20. Okay, so now let's go to the snake. So the snake is going to have a starting length. I'm going to declare this as length, and it's going to be 4 squares, and it's also going to have a move speed of 0.1 seconds, and it will be able to move in 4 directions. So I'm going to declare direction left, up, right, and down, and down, and that's basically it for our global variables. So now I'm going to create the application, which is going to be the heart of the game. So I'm going to declare the snake app, which inherits from the Kivy app. So I'm going to import that as well. And for now it does nothing, and I'm just going to say that if the name of the script is main, then I'm going to create an instance of the app and I'm going to run it. Run. Alright. Okay, so this should basically give us the app. Alright. Okay, so right now it does nothing, but you can see that it has the snake name. So we're basically now going to declare an event loop. So every 0.1 seconds, which is the movement of the snake, I want the snake to move, right? So I'm going to use the onStart event for that. So when the app starts, it's going to call this function, and in this function I'm going to use the Kivy clock from Kivy.clock import clock, and I'm going to use it to schedule an event every 0.1 seconds. So I'm going to say schedule interval, and I'm going to schedule the event self.move every move speed seconds, and then I'm going to declare the event move, and it takes some values that I do not care about, which is the clock event and the time that has passed. And then in this move function method, it's a method, I'm going to do something, right? So I'm going to keep track of where the head of the snake is. To do this, I'm going to use the Kivy properties. So from Kivy import properties as KP, and then I'm going to say that it's a list property which represents a coordinate, so it's going to have a default value of 0, 0, 1 for x and 1 for y. And while I'm at it, I'm going to declare the fruit, which is also a coordinate. Alright, so when the snake moves, I want the head to move to a new location, right? So I'm going to say that the new head location equals something. And for this, I'm going to use the direction. So I'm going to give some values to each direction using a dictionary. So I'm going to say that left corresponds to a movement of -1 in the x-axis and 0 in the y-axis. And then for up, it is 0 and 1. For right, it is going to be 1 and 0. And for down, it is going to be 0 and -1. Alright, so now I can use these values to move the snake in the direction that it's going. And I keep track of the direction by making it a property of the app, a string property that defaults to right and has these options, which is left, up, right, and down. Okay, so then I'm going to obtain the new direction, the new position of the head by using a list comprehension. And I'm going to sum the current location self.head, and I'm going to sum it with the value of the current direction. So I'm going to use self.direction to get that value, and I'm going to zip them so that it returns basically a tuple of the x of the head and the direction, and of the y of the head and the direction, so I can sum them and obtain the new location. And then I'm going to say that the new head equals that head, the new location of the head. Okay, so this is going to basically move the head around. And so we can, in order to draw the snake, I'm going to keep a list of all the positions that the head has been. So I'm going to use a list property for that, and I'm going to call it snake. So if you have seen my other videos, you know that when a Kivy property changes, it will call a function which starts with on _, and then the name of the function. So I can do this by saying on head and defining a function, and this will be called every time the head is changed. And it takes certain values that I do not care about, which is the instance and the new head. So I'm going to do this. I'm not going to use them like that. I'm just going to call self.head. So every time this changes, I want the snake, and I'm going to append the new position of the head. So this should basically move the snake and keep a history of all the locations that it has been inside the snake list. So now I have to draw the sprites, right? So I'm going to use the Kivy for that. So I'm going to go and edit a snake.kv file, which is automatically linked to the app because the app is also called snake. So in here I'm going to declare a sprite widget. This sprite widget is going to have a background color that is white. These positions correspond to red, RBG, so it's red, blue, green, and alpha. And I'm going to say that the size hint is none for X and for Y. This is going to prevent the widgets from expanding to fill the parent, because I want it to have a static size that is going to be twice the sprite size. So I'm going to keep track of the sprite size by saying here sprite size, and it's a numeric property which defaults to the sprite size. Okay, so now I can call it here by saying app.spriteSize, and I'm going to multiply this by 2, so it's 1 for X and 1 for Y. Then I'm going to say that the position depends on a coordinate. So I'm basically going to do this. I'm going to say that the position is a list comprehension of the value of the coordinate times the sprite size for x in self.coordinate. Alright. And then I'm going to paint the canvas. So I'm going to say that the property canvas with a color of RGBA of self.background color, I want you to draw a rectangle with a position of my position, so self.pos, and a size of my size, of self.size. Alright, and then I'm going to declare the class for it right here. So it's going to be a sprite, and it's the basic Kivy widget. So I'm going to import it from kivy.uix.widget, import widget. Okay, and then I'm going to subclass it to create the sprite. And it has a coordinate property, which is just like this one. And it also has a background color, which is also a list property, but it has a default of 4 zeros, one for red, blue, green, and alpha. Alright. Okay, so now I'm going to draw them. So every time the snake changes, the property snake to which I'm appending the head every time it moves, I want something to happen, right? So I'm going to declare a method that is on snake. This is going to get called every time the snake changes, and I'm going to say that for each coordinate in self.snake, I'm going to make a sprite widget, but I only want to make a sprite widget if I need one. So for example, if the snake is of 4 sizes, I only need 4 squares, right? And if it moves, it will still be 4 squares. So I'm going to use a default dictionary to make that easier for me. So from collections, import default dictionary. Okay, and I'm going to, well, a default dictionary is a dictionary that if you call it with an empty key, it will create something for you. Instead of giving a key error, it will create something. So for example, if I wanted to get an index to determine each square, I would use enumerate on the self.snake, so that it returns a tuple with the coordinate and an index that I'm going to use for the dictionary. So I'm basically going to say that the sprite I want to use is in the dictionary that I'm going to create right here. So I'm going to say sprites, and it's going to be a default dictionary that takes a function that will create a new instance of the class that I want. So if I call it with an index that does not exist, it will automatically create a sprite object for me and will give it to me. So I'm going to say the sprite that I want is in sprites with the index of the list, and I'm going to take that sprite and I'm going to say that the coordinate, its coordinate is the new coordinate I'm using right here. And then if it does not have a parent, so if not sprite.parent, then I want to add it to the root widget. So I would say self.root.add_widget, and I would add the sprite. Okay, and now the root widget is going to be the only widget that I declare here that does not have these triangles. I don't know their name. So I'm going to say that this is a relative layout, and since it's not declaring a rule, this is a rule, it's going to be used as the main root widget of the app. So I just declare that it's a relative layout, and now I can use it by calling self.root. So I'm adding the sprites to self.root right here, and this should basically give me a snake that keeps adding to. Alright, so there you can see the snake that it's moving to the right, and it's just creating a widget every time it moves, right? But now I want to limit this to the size of the snake, to the length of the snake. So I'm just going to keep another property here that is going to be length, and it's going to be a numeric property that defaults to the default length. And instead of just appending to the snake, I'm going to create a new list. So I'm going to say self.snake, and this is basically going to be a list comprehension of the snake. So I'm going to use the past snake with only the indexes that I care about. So I'm going to say give me up to the last locations, the last length locations. So I'm going to say self.length, and I'm going to use the minus so that it gives me reverse indexes in a Python list. So it's going to give me the last 4 locations, and then I'm going to add the new head position, and I put it inside a list so that I can sum the lists. So let's see how this works. Okay, so it says index out of range. Okay, I forgot. I have to put 2 dots here so that I use the indexes. Alright, so there you can see that the snake changes. It's always in a size of 4. So now you can see that when the snake moves out of bounds, nothing happens. So I'm going to say that the snake should die when that happens, right? So every time I move, I'm going to check if the new head is within bounds or not. So for that, we're going to create a function. It's going to be check in bounds. So I'm going to define this method, this function, which is going to take self and a new position. And in this method, I'm going to return if the position is within the bounds. So I'm going to make a condition which if all positions are greater or equal than 0, and they are also smaller than, lesser than the dimension x in, for each x and dimension in enumerate, and I'm going to say columns for the x and rows for y. So this should basically return if the snake is in bounds or not. So I'm going to call it right here, if self.check in bounds. If not, if the new position is not in bounds, then I'm going to die, and if it is in bounds, then I'm going to move the head. Let's see how this works. Alright, let's see. Alright, and then it says that I do not have a function named die, so I have to make one, right? So I'm going to define die, and what this is going to do is going to let the user know that it's going to die by flashing the screen red. So I'm going to use the canvas as well. So I'm going to copy it, and then I'm going to put it here. But I'm going to use a color of red. So it's going to be red, green, blue, and alpha. I'm going to animate this, so I'm going to use app.alpha. Alright. And then I'm going to keep track of that alpha. So alpha is a numeric property which defaults to 0, and then I'm going to use the Kivy animation to animate that property. So from Kivy animation, import animation. Alright, and then I'm going to use it right here. So I'm going to create an animation that will move the property alpha to 0.5, but then I'm going to define a variable for this, so it's going to be alpha, and it's going to be of 0.5. Then I can use that constant for cleaner code. Then I'm going to move the alpha to be from 0.5. I'm going to make it from 0.5, so I'm going to say self.alpha equals alpha, and then I'm going to animate that property so that it reaches 0 again. So, and I'm going to give it a duration of the move speed, and then I'm going to start that animation on the app. So I'm going to use self. So let's see if that works. The screen should flash red for a second. Alright, there it goes. But it keeps dying and dying, so I have to reset the state of the snake. So when I die, I also want to create a new random position for the head of the snake. And I also want to clear the snake. So I'm going to say, I'm going to create a function that returns a new head location. And I'm going to make sure that it returns it within the bounds. And I'm going to use this as a property. As a Python property. So what this is going to let me do is call it by doing this. So I'm going to start the animation, and I'm also going to set that the new head equals self dot new head location. For now I'm going to return 0, 0. And I'm also going to say that the snake should be clear. Self.snake.clear. Alright. Okay, so now I have to make sure that the coordinate that this returns is within the bounds. So I'm going to use the random for that. So from random import randint. Okay. And I'm going to tell it to return, and I'm going to use 2 so that it's not too close to the boundaries, and I'm going to use the dimension -2 for each dimension in columns and the rows, like that. So this should give me a new location. Let's test this. Alright, so when the snake dies, it should be in a whole new position, but random is not defined. So I have to say random right here. Okay. Let's see. So it should just die and appear in a new position. Alright, you can see that that happened correctly. Okay. But the widgets are not clearing, I'm just clearing the snake. So I'm going to have to clear the widgets too. So self.root clear widgets. Alright. Alright, now the snake dies and everything, but now it has a way to lose, but it has no way to win. So let's give it a way to win. So we're going to let it move for now. So every time the snake moves, I want to be able to change the direction, right? Okay. So then I'm going to use the keyboard for that, and I'm going to need to bind the app a certain method to the window. So I'm going to say window.bind. I'm going to bind the keyboard on keyboard event, and I'm going to bind it to a method that is going to be called key handler, and this is going to take a lot of arguments, so let's see what it takes. Key handler, I'm going to take everything, and then I'm just going to print it so I can see what it is. Okay, so when I click, so it takes 4 arguments, and one of them is the letter, which I care about, so I'm going to use that one. Okay, so then I'm going to say that I do not care about this argument, I do not care about this either, and I'm going to use this as a key, and I do not care about this one either. Alright, so this should basically give me the key. Print key. Okay. Alright. 6 were given. Okay, so I'm missing another argument. I'm just going to say like this. Alright, let's see. This is giving me the key code. So I probably need another one in between these. Alright. Alright. Alright, so now it prints the letter. Then I have to assign this letter to which direction, right? So I'm going to use direction keys, and I'm going to make a dictionary that says that A corresponds to left and W corresponds to up, then D corresponds to right, and then S corresponds to down. Alright. Okay, and then I'm going to make a try so that if I press a key that is not in that dictionary, it doesn't crash. So I'm going to say, I'm going to tell it to print the new direction. So I'm going to print direction keys by the key, and I'm going to accept a key error, and I'm going to do nothing if that happens. So alright, so you can see that it's printing the directions correctly. So now I have to change the direction, right? So I'm going to say self.direction equals the new direction. But first I have to make sure that the snake can move in that direction. So I'm going to call a try change. I'm going to make a method that is called try change direction, which is going to check if the direction is available. So I'm going to use direction keys for the key. Okay. And I'm going to define the try change direction. This is going to take a direction. Let's just give it a name, new direction, so that we don't mistake it for the other one. So for example, if the snake is going up and I want to change the direction down, it's not possible because I would have to change it to a side first. So I'm going to give these directions another dictionary that is going to say direction groups. Direction group, and then I'm going to use that. I'm going to say that left corresponds to the horizontal direction, and then up corresponds to the vertical, right corresponds to horizontal, and down to the vertical. Alright, so now I can see if it's possible to change to that direction. So I'm going to say that if the new direction, if the group, so direction group of the new direction is not the same as the direction group of the current direction, then I can change the direction. So I'm going to say save direction equals new direction. Alright. Okay, so now I can move the snake around. Perfect. But when I crash into myself, nothing happens and I should die. So I'm going to modify this so that it also checks if I'm not colliding with myself. So if not, or if it's not within bounds, or if the new head is in the snake, then it should die. So let's try that. Okay, so it works correctly now. I can die if I crash into myself. And I'm going to say that when I start, I want to make the snake appear in a random location. So for that, I'm going to say that head equals to the new head location. Just like that. Should basically give me a new start every time. There it goes. So now I'm going to place the fruit. For that, I'm going to create a new rule for fruit. So I'm going to say fruit, and this time it has a background color of 0 in red, 1 in green, 0 in blue, and 1 in alpha. Okay. And then I'm going to create its class right here. So class fruit, and it's an inherits from Sprite, and it does nothing different from it, so that's fine. So when I start, I want to create a fruit, or I can just create it right here. So self.fruit equals a new fruit. Alright, and then I'm going to say that it's a fruit sprite, because just so I don't get it all mixed with this. So fruit sprite, and this time it is an object property, and it's of class fruit. Okay. So then when I start and every time I die, I want to create the fruit in a new location. So I'm going to make this, going to make another method that gives me a new fruit location, and this time it's basically going to be the same, but it can also be in the edges. Alright, like this, because I'm not sure if it's going to appear on the edge or not. Alright, let's try. And then I'm also going to check if it's not inside the head. So I'm going to say that while true, create a new location, and then I'm going to check if it's not in self.snake, and if it's not, I'm going to return it, just like that. So it's going to create fruits until I get one that is not inside the snake already. Okay, so then I can do this, and I can say that self.fruitSprite.corn equals a new location. Just by doing this, self.fruit equals self.new fruit location. Alright. And then I want something to happen when I change the location of the fruit. I will also make sure that it's not already on the same position that it was. So it does not equal self.fruit. Okay. And then every time the position of the fruit changes, so on fruit, I'm going to make sure it's in the canvas. So I'm going to say if not self.fruitSprite.parent, then I'm going to add it. So self.root.addWidget, I'm going to add the fruit widget, the fruit sprite. Okay, so this is going to happen every time the fruit changes. And then every time I collide with the fruit, I'm going to eat it. So if new head equals the fruit, then I'm going to give a new location to the fruit and I'm going to grow in size. So self dot length, and I'm going to sum 1, and I'm going to add a new location. Change the fruit to a new location. So fruit equals self dot new fruit location. Okay. And then also when I die, I want to make sure that the length of the snake returns back to normal. So I'm going to say self dot length equals the default length. Alright, let's test this. So the fruit is right there at the bottom. Let's see if I can grab this. Oh, I did not. And I died and the fruit did not appear in a new location. So let's see what happens there. I'm correctly adding it, but then it looks like I'm not changing the location of the fruit when I die. So it's right here. That is correct. So when I die, I want to make the fruit go to a new location. Alright. Okay. I don't seem to be colliding with the fruit. Why could that be? Okay, it's because I'm not passing the coordinate variable. So every time the fruit changes, besides adding it, I will also say that the new fruit location, the coordinate of the fruit sprite is the new fruit location. So that should fix all the issues. Alright, so there. Okay, and obviously I have to move the fruit after I clear the widgets, right? So that it draws them. So I'm going to put everything that I want before I clear. I'm going to put clear at the start, and then I'm going to add everything else. Clear and animation. Then I'm going to clear the snake. Then I'm going to clear the state of the app. So let's see. Okay, so now when I die, the fruit moves to a new location. And that's basically it, guys. We can have a snake that grows when it eats the fruit, and it can die when it crashes into itself. But the controls are a little bit clunky, so let's implement a new technique. So instead of just changing the location when the user puts it, I want the user to only be able to change the location once per turn. So I'm going to block the input once a direction has been received. So I'm going to say block input, and it's going to be a Boolean property that defaults to false. And I'm going to say that every time I try to change the direction, if I was successful in changing it, then I'm going to block the input. So I'm going to say that block input equals true. And then I'm going to say that if the input is blocked, I'm going to buffer the new direction. So self.buffer direction equals the new direction. So what this is going to do is that I'm only going to be able to change the direction of the snake once per turn, but if I click it another time, the next turn is going to change it automatically for me. So this is called buffering, and I'm going to say that the buffer direction is this one, and then I'm also going to unblock the input every time I move. Alright, so now the input is unblocked. And then if I have a buffered input, then I want to change it once I move, right? So I'm going to say that if self.buffer input buffer direction, then I'm going to say that I'm going to try and change my direction. Self.try change direction for self.buffer direction. And then I'm going to clear it. So I'm going to say that buffer direction is none. And then I'm also going to tell this Kivy property to accept none. So I'm going to say allow none. Or I could also just say that it also takes an empty string, just like that. Then once I use that buffer direction, I'm going to say that the buffer direction is none. Alright, so let's see how this works. I have a syntax error on line 97. Alright, there it goes, just like that. Okay, so now I can make this. Alright, now I can make this chain easily, and the controllers are much smoother. So now I can only change the direction once per turn, but if I click another time, it's going to buffer it so that next time it is able to move, it's going to move. Alright guys, we did it. We made the classic snake game in Python using Kivy in under 1 hour. I hope you liked this video, and please let me know what you would like the next tutorials to be about in the comment section below. See you later guys, bye!